This is the White Belt Class 4 video. Today we're going to be doing the White Belt Kata, so make sure you're brushing up on that. And then we're going to be talking about variables and constants. I want to talk in this video about variables and constants a little bit, kind of run through what those concepts are, and then I'm going to turn you loose. Definitely take a look at both the exercise video for the White Belt Kata as well as the activity video for variables and constants so you can dive more into them. Let me pull up, I've got a Miro board to kind of help us walk through the concepts of variables and constants. So imagine for a moment, we have some code here in this box. So we say customer, my customer equals new customer, Chad 76016, my zip code. The my customer is the variable. The new customer, Chad 76016, is the object. So one of the ways that you can think about variables and objects is that a variable is a container that holds an object. And that's not a terrible analogy, but it's not exactly accurate. It's not exactly fully bulletproof here. Really, it's more accurate to think of a variable, so this box here, as a pointer. So it's a named pointer to some object. So a variable doesn't have an object in and of itself. It simply points to an object. So look at this arrow here. This is pointing up to the object that is the customer. So this my customer is a customer. So we can see that here. New customer. We're creating a new customer object in memory. So this is going to create this customer object in memory. Now this customer object has a first name and a zip code. We can see that here. Those are additional objects in memory. So this customer object also points to the string object Chad and the string object 76016. We call this a complex object because it's not just the data here, it actually references other data, other objects as well. So these over here are objects, and then on the left we have the variable. So the variable doesn't have the object, it simply points to the object in memory. It has a reference to it so that we can look it up. So anytime we say my customer, we're using the object in that variable. So there's a distinction between variables and objects. Objects are the actual data elements in memory. These are the actual values, the actual information. Variables are named pointers. The name is important. That's how we can reference a variable, is by whatever that name is. This variable name is my customer. It's just what I call the name of this particular box. This variable points to an object in memory. So that's what's going on with our variables here and our objects in memory. So let's look down here. Let's say customer, other customer. So this box name is other customer. So this variable up here on top is my customer. This variable here below it is other customer. Both are going to have customer objects, but they're two different names, therefore two different locations in memory. What I'm doing is I'm saying other customer equals my customer, which is this variable here. We're saying other customer is pointing to my customer. What actually happens, you don't actually point this here. That's not what happens. What happens in memory is the object to which my customer points is also allocated as a reference. So when we say other customer equals my customer, what we're really saying is other customer equals the object to which my customer points. So what the runtime is going to do is it's actually going to point to the same object in memory. So now my customer and other customer both point to the same object. That's important to understand. If I change the value of first name to Stephen, both of these variables point to the same object. Therefore, both of these variables will reflect a change in the value of first name. So the objects over here on the right, the variables are over here on the left. The objects don't really have a name. The customer does because I created a first name, but it's just an object. It doesn't have a name. You can't reference this customer by anything. The variables have names. In fact, they are names. They're named pointers or addresses to the actual objects in memory. If I change this and say instead of equals my customer, I say new customer and I pass Alex 76018, then what's happening is it's creating a new object in memory and it's going to point to that other object in memory. Now, these two lines of code, they're two different variables, but they point to two very different objects in memory. The first one is pointing to this object. The second one is pointing to this object. So that's what's going on with variables as they relate to objects and how all the data types work. One more thing I want to point out, strongly typed languages or statically typed languages is probably a better way to describe them, include C# and Java. Dynamically typed languages include JavaScript and Python, and most of the other languages will fall into one of those two camps. The differences are with C# and Java, if you're dealing with a statically typed language, the variable also has a specific data type. So in all languages, the objects have data types. That is necessary to make it a strongly typed language. That is what needs to happen. But in statically typed languages, the variables are also strongly typed, meaning that I'm declaring not just my customer, I'm saying the shape of my customer is customer. So this variable, because of this customer here in front of it, my customer box can only point to customer objects. I can't make this point to just a string. This will not work. This will not function. In fact, it'll give me a compilation error. It won't even let me do that. So that's C# and Java. It requires the data type for the variable in addition to the object. So let's switch gears. JavaScript and Python, these are dynamically typed languages. Python doesn't even have a keyword, but Java, you might use var or let. There is no data type of it. What that means is the variable itself doesn't have a shape. So in JavaScript and Python, I can absolutely point a variable to a different data type. This actually works in JavaScript and Python. This does not work in C# and Java. Now you might think that that's a weakness in C# and Java. However, the strong typing does give us compile time checking, which you get in strongly typed languages or statically typed languages like C# and Java. You don't get compile time checking in Python and JavaScript. The IDEs can do a better job over time of trying to isolate those, but that is a trade-off. So you do get to see the errors earlier in statically typed languages. You don't get to see that in dynamically typed languages. So a little bit about variables, data types, and how those things play out. So now let's switch gears. Let's talk about constants. So a constant is a variable. So it is a named container in memory that points to an object. Just like a variable, a constant is almost identical in every respect. It is a named container. So this constant's name is number. It's not a great name, but that's fine. Its name is number, and it points to some object in memory, the number 347. What's different about a constant is once you assign it to a value, you cannot reassign that constant. I cannot then reassign it to some other value. It doesn't matter what that value is. Constant means once it's defined, once this arrow is set up, that arrow is immovable. I can never change this relationship. So this relationship, in fact, let me see if can I bold this somehow? I'll just change the color. So this relationship in a constant can never be changed. In a variable, I can change it. I can then change my customer and set it to other customer. And now these point to the same object. That is fine with variables. But with constants, you can never reassign number to something else. It is always 347. So a constant is still just a variable, except it doesn't vary. It is constant as the northern star. So the value once assigned can never be reassigned to anything else. It can never be changed. Most of the languages support constants. It is important to know that Python does not have constants. There is no such thing as a constant in Python. By convention, it'll use screaming case, so all caps with underscores. So if you see that, it probably means it's supposed to be constant, but there's nothing that mandates that it must be constant. So a little bit about constants there. So again, constant is just a variable that cannot change its value or its reference. So now let's look at an example where we don't have variables. So these are 2 lines of code. Let me just make a little bit more space so it's clear to see. So this first one, this line of code, it is an executable line of code. We're creating a new customer, Chad76016. This will create an object in memory, but because there's no variable on the left of it, like this, customer equals that, this object gets created in memory and is immediately thrown away. It's eligible for garbage collection. So this doesn't effectively do anything. It creates an object in memory, but we can't use it. We can't reference this customer because we have not assigned it to a variable. That is incredibly important. You don't use objects when you're programming. You use variables which point to objects. So that is incredibly important to understand. So simply creating a new object doesn't help you at all. You must assign a variable using the equal sign. You must create a variable and assign the object to that variable in order to use the object. Let's look at this second line down here, console write line Alex. This also is creating an object in memory and immediately throwing it away. It is doing one thing in between, which is saying when I call write line, pass Alex to the argument for write line. So it is going to use that, but I cannot reference this variable, or this object rather, after this line of code. There is no variable name that I can get. Alex doesn't exist. That's not a variable. I didn't create a variable, if I can spell. Right? That is not, this Alex and this Alex are not the same thing. This is an object of type string. This would be some variable named Alex that does not exist. If I wanted to call the variable, I would need to create a variable, var Alex equals Alex. Now I can use the name Alex down below as a variable that points to the object, and now I can do something with that object. So very important to understand. Hopefully that helps distinguish between objects and variables. So on the top, that is an object. It's not assigned to a variable. The bottom, Alex is an object. We're passing it, but we're not assigning it to a variable, so we cannot use it. So down below here, you can see some examples where we say, okay, customer Chad equals new customer. Now I have this variable. Now later on, I could use that. I could say right line Chad. Now I can use that later. Similarly with name, I can assign name as a variable to Alex, and now I can right line name. So in the first examples here, we don't actually have variables. The second example, we have variables. They're to the left of an equal sign. And now we can use those variables later on in code as we need to. So just wanted to run through that real quick. Definitely take a look in either order, either the exercise for the white belt kata or the activity for the variables and constants. Do some more research, watch those videos. As always, good luck.